Alright everybody, so in this video we are going to be working with this topology. This topology is set up to deal with layer 2 or switch security configurations. This is the logical uh, documentation that we have, basically 5 objectives, and the first, which is to create a secure trunk. Now, to create a secure trunk, what we mean by that and what is the reasoning behind is that this will protect the switch from VLAN hopping, where spoof dynamic trunking protocol messages are sent from attacking host, and that can be done with software that enables the host to act as a switch, right? You can have a computer that have special software that would then turn that computer into behave like a switch. Now that is used to cause the switch to enter in trunking mode. Now from here, the attacker can send traffic tagged with the target VLAN, and the switch then delivers the packets to the destination. Now this also prevents the introduction of a rogue switch and enabling trunking, which will allow the attacker to access all VLANs. And another type of VLAN hopping attack is double tagging VLAN. Now this is an attack where in the frame there will be, normally it's only one VLAN tag, right? But in this case the attacker will double tag. It will have two tags. It's gonna have the normal one, and then behind that one is gonna have the one that that attacker is really intending to get to, right? So what's gonna happen is that the attacker, right, will take and will double tag the frame, right, with two headers, right? That the outer header has the VLAN tag of the native VLAN of that particular trunk port, but the inner tag is the victim VLAN. The sending switch will only see the outer tag for the native VLAN, and because it is the native VLAN for that particular trunk, the tag will be removed and the frame does not get retagged, right? When the destination is the native VLAN, that doesn't require the switch to retag, right, before sending that frame towards the wire, that trunk link. It will remove that tag and then send the frame without a tag. The receiving switch that get that on tag frame, automatically it will put it in the native VLAN. That's why when a switch is sending a frame that is destined to the native VLAN, it will remove that tag and it's not going to get reframe, right? So that will leave the inner tag, the one that was behind, right, the original one inserted by the attacker, totally intact. Now when the frame arrives at the other switch, it sees the untouched inserted tag of our attacker, and it will process and it will proceed to send the frame to the VLAN that the attacker specified, or it may flood the frame. Now in part 2, we're going to secure unused switch ports, and this is a simple method that helps secure the network from unauthorized access by disabling all unused ports on a switch. For example, if a Catalyst 2950, like the one I have, has 24 ports, which they do, and there are 3 fast Ethernet connections in use, it is a good practice to disable the other 21 ports that are being in use. Okay, and not only that, they should be also assigned to a unused VLAN. Now in part 3, we're going to implement port security. Now I had a video about port security where I demonstrate the importance of it and the features that we can enable. Now this is used to mitigate against MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attacks is to enable port security, period. Port security limits the number of valid MAC addresses allowed on a port. It allows administrators to manually configure MAC addresses for a port or to allow the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure MAC addresses that were manually configured or dynamically learned on the port. Alright, and again, there's a video that shows the importance of it. Now, part 4, we are going to enable DHCP snooping. Now, a DHCP snooping attack is very damaging. Now, but there are two types of DHCP attacks. Right? There is DHCP starvation and DHCP spoofing. Both attacks are mitigated by implementing the DHCP snooping. DHCP starvation attack, which create a denial of service for connecting clients, and also a DHCP spoofing attack. Now, the DHCP spoofing attack occurs when a rogue DHCP server is connected to the network and start giving away false IP configuration parameters to legitimate clients. Now this will create a man-in-the-middle attack. Okay, it will also give away wrong DNS server, which will then point the user to a nefarious website. Also in that, it will serve wrong IP address. Now this is where an effective denial survey attacks happens, because the computers will receive wrong IPs that are not even in the same subnet, right? So therefore the computers are not going to be able to communicate at all. So that is an effective denial service attack. Now lastly, in part 5, we're going to configure rapid per VLAN spanning tree, port fast, and BPDU guard. All right. So by doing that, we protecting from attackers that can manipulate the spanning tree protocol. And with that, they can conduct an attack by spoofing the root bridge and changing the topology of the network. Now, to mitigate spanning tree protocol manipulation attacks, we use port fast and bridge protocol data unit guard. Now, port fast immediately brings an interface configured as an access port to the forwarding state from blocking state, right? And that will bypass the listening and learning states. Now, it's really important to keep in mind that it must be applied to all end users ports, right? Port fast should only be configured on ports attached to end devices, all right? Now, the BPDU guard will immediately error disable a port that receives a BPDU frame, right? And just like port fast, BPDU guard should only be configured on interfaces attached to end devices. All right, now that we have that background out of the way, right, and that summary of what we're doing here and the reason why, now let's jump into configurations. All right, so let's start with configuration, and here we have the topology. Now, again, the first thing that we need to take care of is to create a secure trunk. We need to connect the gigabit 0/2 ports on the 2-access layer switches. Alright, if we go back to the topology, we can see that we're missing that connection between the two switches. Alright, so let's do that. Gigabit Ethernet 0/2. Okay, we have that taken care of. Now the next is to configure these two ports and the gigabit 0/1 as static trunks on both switches. We're going to switch 1 and we're going to use the range command. Interface, well, first on global configuration mode. Okay, now let me go to interface. Let me go to line console 0, and here I'm going to disable the login messages that is going to affect the way we type, right? Okay, so for that we're going to use the login synchronous. Okay, that way we don't have that syslog interfering with what we type. Okay, so we exit. Now we go to interface range gigabit 0/1 and 2, and we're going to configure this port to be static trunk links. For that, we use the switch port mode trunk and switch port non-negotiate. Okay, now we do that on the other switch as well. Okay, terminal, line console 0, and we're going to log in synchronous. Okay, interface range gigabit 0/1 and 2, switch port mode trunk, switch port non-negotiate. Okay, great. All right, now that we had that taken care of, now we have an inconsistent local VLAN. All right, and that's okay because we need to create a VLAN 100 as we see here. So we have A and B taken care of, and C as well. We disable dynamic trunking protocol negotiation with the non-negotiate command. Now we have to create VLAN 100 and give it a name of native on both switches. Then we have to configure all trunk ports on both switches to use that VLAN 100 as the native VLAN. That will get rid of this mismatch, native mismatch configuration. Okay, so we are on switch 2, and we're going to create the VLAN 100. And we're gonna name it native. Okay. Now we're going to go to those trunks, and we're going to specify that we want to use the VLAN 100 as the native. Okay, switch port trunk native VLAN 100. Okay, now the port consistency has been restored. Okay, we need to do the exact same thing on the other end. Okay, and I can type this last command. I can type this right here, this last command that I use on switch 2. If I copy that and I go to switch 1, I can do that right here, and it's going to work, because although we haven't created the VLAN 100 by stipulating this command, the switch will auto create that VLAN, but it's not going to assign a name. I can do that, but I will just go and do the exact same thing that is being asked to do. So I will go exit out of this. I'm going to create the VLAN 100. Okay, that's been created. I'm going to name it native. Okay, now I can go back to my range and specify to use that as the native VLAN to restore consistency. Switch port trunk native VLAN 100. Okay, consistency restored. Good. Okay, now if we go back, we're done with this. Now we're going to step 2, secure unused switch ports. Jot down all the unused switch ports on switch 1. Alright, so let's go ahead and just to see precisely what we have when it comes to interfaces that are not being used. If you guys want to only show the interfaces that are up, right? We can do that with the show interfaces. We can pipe and include, and then use the ones that are connected. Okay, that way we can only see, instead of the regular expression of, because I can use show IP interface brief, and that will also show the same thing, right? But it's a long list, right? And then we have to one by one. Okay, yeah, fast system at 1, 2, and then 10, and then 24, and then gigabit 1 and 2. But we can filter that out by the show interfaces and then pipe to include only the ones that are connected. With this command, it's going to show the ones that are actually up, that are connected and up, right? So we have fast Ethernet 1, 2, 10, 24, and the 2 gigabits. So yes, okay, sorry about that. So yeah, what I was trying to show is that I can use the show IP interface brief, and that will bring about the long list. But if we do the show interfaces pipe include connected, it's just going to bring this short list that has exactly what we're looking for, the interfaces that are up. Okay, so because we need to shut down all unused switch ports. Okay, So we need to shut down all the unused switch ports. We can then specify that interface range fast Ethernet. So from the fast Ethernet 0/3 all the way to 9, those are not being used. We can just shut those down. Okay, so we can just shut down those. Okay, and then the other ones are going to be 11 through from 11, which is the next 10 is being used, so 11 is not, all the way through 23. Okay, so 11 through 23, shut down those. Okay, all right, so those are for switch ports, okay, that are not being used. Perfect. Okay, so that's been completed. Now the next step is to, on switch 1, we need to create VLAN 999. Okay, so it says on switch 1 create VLAN 999 and name it black hole. Okay, and we need to match exactly. And then we have to move all unused switch ports to that black hole VLAN. Okay, good. Let's go back to our switch. Okay, exit. Let's create a VLAN 999. We're gonna name it black hole. Okay. Now the interfaces that we shut down, we're going to move it to that VLAN with the switch port access VLAN 999. Okay, same thing with the other interfaces. Perfect. All right, now what we need to do next is to implement port security. Now activate port security on all the active access ports on switch 1. Alright, so all active ports will be Fast Ethernet 1, 2, 10, and 24. So from 1 to 2, switch port security. Okay, then Fast Ethernet 10, switch port security, and then 24, switch port security. Okay, and I didn't show you guys, but here we are. Okay, so the ones that are in used, so is Fast Ethernet 1, the range from Fast Ethernet 1 to 2, we activate switch port security. Then we went to interface range Fast Ethernet /10, and we enable switch port security on that one. And then we did the same thing on Fast Ethernet 0/24, with the switch port security. Okay. All right. So we did that. That was step 3 A. Okay. Now we have to go B, configure active ports to allow a maximum of 4 MAC addresses to be learned on the ports. Okay, let's go back to the switch. That you had done that. Okay. Well, I'm going to just go one by one, very consistent. So we need to the maximum of. Okay, so on that range. Okay, switch port for security and a maximum of 4. Okay, that took care of Fast Ethernet 1 and 2. Now we need to go to Fast Ethernet. Fast Ethernet 10. And we need to do the switch port for security max 4. Okay. Now let's go to 24. And maximum of 4. Okay. Done with that. Okay, now let's go to the next step. Let's specify that for port Fast Ethernet 0/1 on switch 1, we're going to statically configure the MAC address of the PC using that port. Okay. Alright, so if we go to the topology, here we see that on Fast Ethernet 0/1, we have to go to that PC. Let's go to the command prompt. IP config /all. Okay, the physical address. I'll copy that. Go back to the switch. Let's go to that specific port. Switch port for security and then MAC address. And we paste that MAC address there. Alright. Now the next step is to configure each active access port so that it will automatically add the MAC addresses learned on the port to the running configuration. Okay, let me specify the range. Fast Ethernet 1 to 2. Okay, switch port for security. And if we want to dynamically add the MAC address, okay, so here we are back to the switch, and I went to the interface range of Fast Ethernet 1 and 2, and now to tell the switch to automatically add the MAC address learned on the port to the running configuration, we have to use the switch port for security MAC address and sticky. Alright, that will then add the next dynamic learn MAC addresses to the running configuration. Now remember guys, to be able to survive a reboot, then we have to, at the end, we have to save our running configuration to startup configuration. Alright, now we have to do the same thing on the rest of the interfaces. So we have interfaces fast Ethernet 0/1 and 2 taken care of. But now we have to do the same to the interface fast Ethernet 0/10. And we have to do the same thing on 24. Sticky. All right, good. All right. Now we have to configure the port security violation. Configure the port security violation mode to drop packets from MAC addresses that exceed the maximum allowed, to generate a syslog entry, but not disable the ports. Okay. So we are on Fast Ethernet 0/24 interface. Okay, so for that, let me go back to the switch. Okay, so since we're already on the interface Fast 0/24, okay, to assign the violation, switch port for security violation. And remember, guys, we have 3 different options: protect, restrict, and shut down. Now, specifically, they want the violation that will drop packets once we maximize the learned MAC addresses, but they want to generate a syslog entry and at the same time not shut down the port. Now, obviously, shut down is going to shut down the port, right? These other 2 will not shut down the port, but protect will not generate a syslog. All right. Restrict mode, those 2 will not shut down the port, but the only one that will generate a syslog is restrict. So we're going to use restrict. All right. Now we have to do the same thing on the interface 10 as well. Okay, and we also have to do the same thing on the range 1 and 2. Okay, perfect. Now the next step is to configure DHCP snooping. Alright, so we are going to configure the trunk ports on switch 1 as trusted ports. Alright. And that is the gigabit 0/1 and 2. Okay, now here we're going to do the activate those interfaces as trusted by DHCP snooping. Snooping trust. Okay. See, so you guys can see. All right, so I went to the interface range of the trunk ports, which is gigabit 1 and 2, and then I use the command IP DHCP snooping trust. Okay, so that is done. Then we're going to limit. Okay, we're going to limit the rate to 5 messages on the on trust ports, right? So everything else will be, other than these two, everything is going to be on trust. So we limit the rate to 5. Okay. All right. So now that we have that completed, now we have to go to switch to and enable DHCP snooping globally and for the VLANs 10, 20, and 99. Okay. All right. So let's go to the switch. Configure terminal. And globally means in global configuration mode. We're going to use IP, DHCP, snooping. Okay, and to activate that, we're going to use the VLAN 10, 20, and 99. Okay. All right, so we're going to specify that there. Okay. All right, now the last step, if we go back, if you notice it, when you do this packet tracer, you notice that the DHCP commands may not score properly on packet tracer, so you may not see the completion percentage increasing. But that is a packet tracer bug, you can say. All right, so moving on to step 5, configure port fast and BPDU guard. All right, so enable port fast on all access ports that are in use on switch 1. Okay, so we're going to switch 1. Here we are on switch 1. And again. Now, port fast, remember guys, is only done on access ports, right? So fast 0/1 and 2. And we're going to do spanning port fast and BPDU guard. Okay. Enable. Okay. We have to do the same thing for the other interfaces. Interface fast 0/10. Spanning tree port fast. Okay. And BPDU guard enable. Okay. All right. Now we have to go and do the same on the other interface, which is the 24th. Port fast. And BPDU guard enabled. Okay. Now, lastly, we need to go and to switch to and do the same, but globally, right? So we need to configure switch to so that all access ports will use port fast by default. Okay, let's go back to our switches. Switch to, I'm in global config, spanning 3, port fast, and default. Okay, and that is all that we need to do. Okay, so you guys can see on the bottom left corner the completion percentage is 100%. Check results. Okay, and here we have congratulations. Okay, on completing this activity. So everything's been checked out. All configuration has been 100% completed. Okay, so this was a nice condensed exercise that walk us through what is a standard and basic configuration, security configurations for layer 2 switches. And I hope that this video will be helpful to you guys, and I'll see you in the next